Good morning, students. Last class we discussed 18th group elements called noble gases, their atomic properties, electronic configuration and some of the physical and chemical properties. Then today's discussion is compounds of xenon. Compounds of xenon, and this first one is xenon fluorides. As we already discussed, the first noble gas compound is xenon hexafluoridoplatinate 5 complex that was prepared in the year 1962 by Neil Bartlett by reaction with xenon and platinum hexafluoride. Adinpa andre last class discuss ಮಾಡಿವಿ. Then we will see some of the compounds of xenon. In this first one is xenon fluorides. Xenon directly reacts with different amounts of fluorine and forms 3 binary fluorides such as XeF2, XeF4 and XeF6. These are the 3 binary fluorides are formed with reaction, direct reaction with xenon and different amounts of fluorine under suitable condition. Xenon directly reacts with different amounts of fluorine and forms three binary fluorides as XeF2, XeF4 and XeF6 under suitable conditions. These are the 3 important xenon fluorides obtained by direct reaction with different amounts of fluorine under suitable conditions. Here, when xenon reacts with fluorine, these two are gases in the ratio 2:1. In presence of nickel tube at about 673 Kelvin temperature and 1 bar pressure to form xenon difluoride. It is a solid. This is xenon difluoride is formed under different conditions. When xenon reacts with fluorine in the ratio 1:5. 1:5 ratio the xenon reacts with fluorine in presence of nickel tube at about 873 Kelvin temperature and 7 bar pressure to form XeF4 solid. It is called xenon tetrafluoride. tetrafluoride. And lastly, when xenon reacts with fluorine, in the ratio 1:20, 1:20 ರೇಷಿಯೋದೊಳಗೆ ಏನಪ್ಪ ಅಂದ್ರೆ xenon reacts with fluorine in presence of nickel tube at about 575 Kelvin temperature and 60 to 70 bar pressure, it forms xenon hexafluoride. This is xenon hexafluoride is obtained. Xenon directly reacts with fluorine with different amounts to form 3 binary fluorides such as XeF2, XeF4 and XeF6 in different conditions. These are the methods of preparation of xenon fluorides. Next is properties of xenon fluorides. Next is properties. And also one more, this xenon hexafluoride can also be prepared by interaction with xenon tetrafluoride with dioxygen difluoride. This can also be prepared. One more, XeF4 on interaction with O2F2 at about 143 Kelvin temperature, it forms XeF6 plus O2. This xenon hexafluoride can also be prepared by the interaction of xenon tetrafluoride with dioxygen difluoride at about 143 Kelvin temperature. Next is preparation, properties. Properties of xenon fluorides. Properties of xenon fluoride. First property of xenon fluoride is all the xenon fluorides are colorless crystalline solids. All the xenon fluorides are colorless crystalline solids. All xenon fluorides are colorless crystalline solids. This is the first property. Second one is they sublime at 298 Kelvin temperature. All these sublime at 298 Kelvin temperature. They sublime at 298 Kelvin temperature. Then third property of xenon fluorides, these are acts as a powerful fluorinating agents. All the xenon fluorides acts as powerful fluorinating agents. They acts as powerful fluorinating agent. For example, let us consider xenon tetrafluoride reacts with SF4, it gets converted into xenon plus SF6. It acts as a good fluorinating agent. ಅಂತಂದ್ರೆ ಫ್ಲೋರಾನ್ ಅನ್ನು ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಡೊನೇಟ್ ಮಾಡ್ತದೆ. Similarly, XeF4 reacts with platinum to form Xe plus PtF4. Then fourth property of xenon fluoride is these are readily hydrolyzed even by a trace amount of water. These are readily hydrolyzed. These are readily hydrolyzed even by a trace amounts of water. ಸ್ವಲ್ಪ ವಾಟರ್ ಇದ್ದರೂ ಏನಪ್ಪ ಅಂತಂದರೆ these are hydrolyzed. For example, XeF2 on hydrolysis gives Xe plus 4HF plus O2. Similarly, XeF4 on hydrolysis with traces of water, it gives Xe plus XeO3 plus 6HF plus O2. These are the 8. Okay. These are the hydrolysis with traces of water. Then fifth one is xenon fluorides reacts with fluoride ion acceptors to form cationic species and with fluoride ion donors to form anionic species. Fluoride ion acceptor ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದರೆ ಕ್ಯಾಟಯೋನಿಕ್ ಸ್ಪೀಸಿಸ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತದೆ. ಫ್ಲೋರೈಡ್ ಅಯಾನ್ ಡೋನರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅಂತಂದರೆ ಆನಯೋನಿಕ್ ಸ್ಪೀಸಿಸ್ ಫಾರ್ಮೇಷನ್. xenon fluorides reacts with fluoride ion acceptors to form cationic species and with fluoride ion donors to form anionic species. For example, let us consider XeF2 reacts with PF5 to form XeF plus PF6 minus. This xenon difluoride acts as a fluoride ion donor and this acts as a fluoride ion acceptor. These xenon fluorides reacts with fluoride ion acceptor. PF5 acts as a fluoride ion acceptor and these xenon fluorides form cationic species. Similarly, xenon hexafluoride reacts with metal fluorides to form M plus XeF7 minus. These xenon fluorides reacts with fluoride ion donors. This acts as a fluoride ion donor and it forms anionic species. Here metal ion M is sodium, potassium, rubidium and cesium. These are the M. Metal fluorides reacts with xenon fluorides and metal fluorides acts as a, these are fluoride ion donors and the xenon fluorides form anionic species and xenon fluorides reacts with fluoride ion acceptor to form cationic species. Okay, these are the some of the chemical properties of xenon fluorides. Next is xenon oxides or xenon oxygen compounds. Next is xenon oxides. Xenon oxides or xenon oxygen compounds. Xenon forms two types of oxides such as XeO3 and XeO4. Xenon forms two types of oxides such as XeO3 and XeO4. These are the two different types of oxides formed when xenon combines with oxygen. In this, first one is xenon trioxide. Xenon trioxide, XeO3. This xenon trioxide is prepared by hydrolyzing xenon tetrafluoride and xenon hexafluoride, XeF4 and XeF6 on hydrolysis to give xenon trioxide. It is prepared by hydrolyzing XeF4 and XeF6. ಇವೆರಡೂ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ xenon trioxide is obtained by hydrolyzing XeF4 and XeF6, and the first reaction is XeF4 on hydrolysis gives XeO3 plus 24 HF plus 3O2, and this xenon trioxide is obtained by hydrolysis of xenon tetrafluoride. Similarly, xenon hexafluoride is also hydrolyzed to form XeO3 plus 6HF. These are the two reactions for the preparation of xenon trioxide, and this xenon trioxide is a colorless explosive substance. This is a colorless explosive substance, and the structure of this is pyramidal structure and geometry is tetrahedral. We will see later. Then second one is xenon tetroxide, XeO4, xenon tetroxide, that is XeO4, and this xenon tetroxide is prepared by the action of concentrated sulfuric acid on sodium or barium xenate at room temperature. It is prepared by the action of concentrated sulfuric acid on sodium or barium xenate compounds are Na4XeO6 or Ba2XeO6 at RT means room temperature, and the chemical reactions are Na4XeO6 on action with H2SO4, it gives XeO4 plus Na2SO4 plus H2O. Similarly, Ba2XeO6 plus H2SO4 at room temperature to form XeO4 plus BaSO4 plus 2H2O. This xenon tetroxide is a yellow crystalline explosive solid. It is also, these two are explosive solids, and the structure and geometry of XeO4 is same, that is tetrahedral, but the geometry is differ than the actual structure of XeO3 is due to the presence of one lone pair of electron. We will see later. Next is, this completes the xenon oxides. Next one is xenon oxyfluorides. Oxyfluorides. Xenon forms two types of, or two xenon oxyfluorides, namely XeOF4 and XeO2F2. Xenon forms two types of oxyfluorides, namely XeOF4 and XeO2F2, and these are prepared or obtained by partial hydrolysis of xenon hexafluoride. These oxyacids, oxyfluorides of xenon are obtained by the partial hydrolysis of XeF6. Iverdu enpa antara xenon oxyfluorides can be obtained by partial hydrolysis of xenon hexafluorides, and chemical reactions of this is XeF6 plus H2O gives XeOF4 plus 2HF. This is xenon oxy tetrafluoride. This is called xenon oxy tetrafluoride. And similarly, xenon hexafluoride on partial hydrolysis with water to form XeO2F2 plus 4HF. This is called xenon dioxy difluoride or dioxygen difluoride. Dioxy difluoride or dioxygen difluoride. These can be obtained by partial hydrolysis of xenon hexafluorides. These are the some of important compounds of xenon. First, xenon fluorides, xenon oxides and xenon oxyfluorides. Then we will see the structures of xenon compounds. Structures of xenon compounds. The structures of xenon compounds can be explained on the basis of valence shell electron pair repulsion theory as well as hybridization concept. ಇವೆರಡರ ಮೇಲೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ structure of xenon compounds can be explained. Structures of xenon compounds. These structures can be explained on the basis of valence shell electron pair repulsion theory and hybridization concept. We will see. First is molecules or compounds then hybridization of central xenon, then total number of pairs of electrons around central xenon, then number of bond pair electrons number of lone pair electrons actual geometry and last one is true structure of compound. True structure of molecule or compound. Here first is XeF2. There are 5 to 6 compounds. One, 2, 3, 4, 5, 6. There are 5 compounds 6 or XeF4, XeF6, XeO3, XeO2 or XeOF4. These are the 5 important compounds and their structures and their hybridization. Here, first one is Xenon Difluoride. First we will write the ground state electronic configuration of xenon in general. This is NS, NP, ND. Xenon is completely field stable electronic configuration, that is NS2, NP, NP6 configuration. And in the first excited state electronic configuration, I will write first, second and third excited state electronic configuration of xenon. These are the vacant d orbitals, and this is the ground state electronic configuration. And in the excited state electronic configuration, first excited state electronic configuration, one of the paired electron in p orbital is shifted to the vacant d orbital, and it forms two unpaired electrons, and these bonding with fluoride ion, and it forms sp3 dehybridization. This is the first excited state electronic configuration. In the second excited state electronic configuration, one more paired p electron is unpaired and shifting to the vacant d orbital, and it forms 6 equal energies of hybrid orbitals, and the hybridization of this xenon is sp3d2, and it forms 4 fluorine xenon bonds because of 4 unpaired electrons. And in the third excited state electronic configuration, all the 3 paired p electrons are unpaired and shifting to the vacant d orbitals, and it forms 7 equal energies of hybrid orbitals, and the hybridization of central xenon is sp3d3. Based on these excited state electronic configuration, we can predict the hybridization, total number of bonding electrons and lone pair of electrons, or total number of electrons around the central atom. Here Xenon difluoride forms sp3d hybridization, because in the first excited state only two unpaired electrons in the hybrid orbitals, and these two hybrid orbitals form bond with fluorine, and the hybridization of central xenon in this XeF2 is sp3d, and total number of bonding electrons 2, 4, 6, 8 bonding electrons ಎಷ್ಟದ ನೋಡ್ರಿ bonding electrons means we count the number of hybrid orbitals 1, 3, 5 number of pairs means ಎರಡೆರಡು electrons, total number of pairs of electrons around xenon is 5. ಅದರೊಳಗೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಬಾಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟದ ನೋಡಿ ಬಾಂಡ್ ಪೇರ್ಸ್ only 2, because 2 fluorine atoms are bond with xenon and remaining electrons are lone pair of electrons 2, 3, 5, and the geometry of sp3d hybridization is square or trigonal, bipyramidal. But the actual structure of this is linear, because all the three lone pair of electrons occupying in the equatorial position and fluoride ions are in the axial position, and the actual structure is linear, and the structure of xenon difluoride is F, this is the linear structure, this is XeF2. Then second one is XeF4. In the second excited state, the hybrid orbitals are formed, the hybridization of central xenon is sp3d2, total number of electron pairs around the xenon is 2, 5, 6, and total number of bond pairs around the xenon is only 4, because 4 fluoride ions bonded with xenon, and lone pair of electron 2, and the expected geometry of this is octahedral. ನಮ್ಗೆ ಗೊತ್ತದೆ, because sp3d2 hybridization ಇತ್ತು ಅಂತಂದ್ರೆ octahedral geometry ಇರ್ತದೆ, sp3d ಇದ್ರೆ trigonal bipyramidal ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ geometry ಇರ್ತದೆ. This is ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ okay. Then the geometry of sp3d2 hybrid state of XeF4 is octahedral, but which contain two lone pair of electrons, and its true structure is square planar. And the structure of this is XeF, and there are two lone pair of electrons, one above and one below. Now ಏನಪ್ಪಾ ಅಂದ್ರೆ geometry is differ than actual structure, It contains lone pair of electrons. ಯಾವಾಗ lone pair of electrons ಇರ್ತಾವಲ್ಲ ಅವಾಗ geometry and structures are different, and it is a square planar structure. Square planar XeF4. Then next is XeF6, xenon hexafluoride. In the third excited state, it forms sp3d3 hybridization, and total number of electron pairs are 7. In that, 6 fluorine atoms are bonded and 1 lone pair is present, and the sp3d3 hybrid state of xenon having its geometry is pentagonal bipyramidal. Its geometry is pentagonal bipyramidal. But due to the presence of one lone pair, its structure is distorted octahedral, and the true structure of this is Xe F distorted octahedral due to one lone pair. This is octahedral XeF6. Due to one lone pair, it is a distorted octahedral geometry. Distorted octahedral. Next is XeO3. It forms 3 covalent bond with oxygen, and that is in the here. This is sp3 hybrid state. It forms these three unpaired. In the third excited state, it forms only 3 covalent bonds with p orbitals, and rest of these 3 unpaired d orbitals are forming pi bonds, and these are not involved in the hybridization, and we will consider only sp3 hybridization. And it contains total 4 bonding electrons. In that, total number of electron pairs and bonding electrons are 3. Then lone pair is 1, and actual geometry is tetrahedral, and the true structure is pyramidal, and its structure is Xe, 1 lone pair, this is pyramidal XeO3. Then last one is XeOF4. It forms sp3d2 hybridization. It forms sp3d2 hybridization, and in the second excited state. ಇಲ್ಲೇನಪ್ಪ ಅಂತಂದ್ರೆ 4 fluorines are bonded with xenon and 1 oxygen is ಇದು ಏನಪ್ಪ ಅಂದ್ರೆ third excited state ದಲ್ಲಿ ಏನಾಗ್ತದ, these are bonded with 4 are fluorine and 1 with oxygen, and rest of this unpaired hybrid orbital forming covalent bond, and this does not involving in the hybridization. And bond pair of electrons, total number of electron pairs are 6. In that 5 are bond pairs and 1 is lone pair. And sp3d2 hybridization, the actual geometry is octahedral and its geometry is square pyramidal. Because one lone pair is present and its structure is like this. XeOF4. This is the actual structure of xenon oxytetrafluoride. These are the important structures. ಇವತ್ತು ಯಾವುದಾದ್ರೂ ಒಂದು ಏನಪ್ಪ ಅಂತಂದ್ರೆ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ದಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಇದೇನಪ್ಪ ಅಂತಂದ್ರೆ ಟೇಬಲ್ ಒಂದು ಗೊತ್ತಿದ್ರೆ ವಿಲ್ ಡ್ರಾ ದಿ ಸ್ಟ್ರಕ್ಚರ್. And last part of this topic is uses of halogens. Generally, helium is a very light and non-inflammable and which is used to fill air balloons and which are employed in the meteorological observations. Lightweight, non-inflammable irodikkenpa andre these are used to fill air balloons and these are employed in the meteorological observation. And this liquid helium is also used in the cryogenic agents for used in the experiments carried out in very low temperature, because ನಮಗೆ ಗೊತ್ತಿರುವಂಥ ಎಲ್ಲ ಸಬ್ಸ್ಟೆನ್ಸ್ ಒಳಗೆ helium is the lowest melting point. ಅದಕ್ಕೆ liquid helium is used in the cryogenic agent, and this helium is also used as a cooled nuclear reactor. Cooled nuclear reactor ದಲ್ಲಿ ಏನಪ್ಪ ಅಂದ್ರೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Next is uses of neon. Neon is generally used to fill the discharge tube as well as that discharge tube as well as bulbs. Discharge tube, filling of discharge tube, and these bulbs are also used in the botanical garden as well as in the greenhouse. These in Panthera neon filled bulbs are generally used in the botanical garden as well as greenhouse. These are used in the filling of discharge tube and high intensity of bulbs. And next is uses of argon. Argons are generally gas is generally used to fill electric bulbs, and these are also used as a maintain or in the inert atmosphere in welding. It creates inert atmosphere for welding. These are the uses of argon. Then krypton is generally krypton 85 is used for determine the thickness of steel sheets as well as metal sheets or plastic sheets. Adar thickness measure madlikke use ಮಾಡ್ತಾರೆ. And this krypton is also used for filling bulbs instead of argon in the high efficient minor cap bulbs. Minor cap bulbs ಏನಪ್ಪ ಅಂದ್ರೆ fill ಮಾಡ್ಲಿಕ್ಕೆ ಏನಪ್ಪ ಅಂತಂದ್ರೆ krypton use ಮಾಡ್ತಾರೆ. Then xenon is also used in the photographic sheets. ಅದರ photographic ಏನಪ್ಪ ಅಂದ್ರೆ sheets ಏನಪ್ಪ ಅಂದ್ರೆ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then lastly radon is used in the treatment of cancer. Radiotherapy ದಲ್ಲಿ ಏನಪ್ಪ ಅಂತಂದ್ರೆ radon use ಮಾಡ್ತಾರೆ. These are the some uses of 18th group elements, and this completes P block elements, and this is the very important, it covers maximum 10 marks. Okay, this completes the P block elements, and next class we will discuss some of the numerical problems on solution. Thank you.